Okay, what's up everybody? Today we'll be doing No Time to Paint, the second problem in the January contest silver. I think once I finish January, I may head to December. December is a little easier though, but I may start doing gold problems too. I kind of like only the 2021 contest and stuff like that because it uses standard input and standard output, but I mean there's still good problems from like before, like with file input and stuff like that. I hate file input, it's so annoying. But yeah, I also hate infinite input when they don't tell you how much n there is. But anyways, that's just me being a pet peeve type of guy. So in this problem, just imagine like there's a fence, right? These are going to be values or colors on the fence. And so each index represents what color is it is going to be on this like individual piece of fence. And another thing is colors are also represented by letters. So A is a color, B is a color, C is a color. And the higher up, so like let's say A is 1, the lower value it is, the lighter color. So B is a darker color than A, and B is a lighter color than C. So keep that in mind. Yeah. So basically, Bessie wants to, or is it still Bessie? Probably it's Bessie. Yeah, it's always Bessie. So Bessie wants to paint this fence, right? And so her desired fence is A B B A B C B. So B B A B C B. But her goal is to paint it without a certain segment. So in this case, the first case would be 36, I think it was. And basically this is what she wants to paint in. And remember, these have to be blank, which is a weird idea, but these guys have to be blank. And yeah, and what that means is you have to divide the problem into its prefix and its suffix. And you want to find the minimum number of operations such that this substring is possible, or this string is possible. Now, David, how do you color your fence in this case? Well, this is going to be how you had a hiccup. Oh my god. So this is kind of how it works. Basically, if oh no, what am I doing? Okay, so Bessie can only color a contiguous segment at a time. So let's say she wants to color in A, C, B. So just imagine this is a segment that you need to color. And she can color up to a segment of an infinite length, but they have to be the same color. So I can paint all of these A. And like I said earlier, A is lighter than B, B is lighter than C, C is greater than B, or darker than B, and B is greater than A. And that's important because with paint and stuff like that, you can color over it. But you can only color over the way that with darker colors can only color over lighter colors. So B can color over A, but A can't color over B. That's impossible. So the optimal strategy for this one is to, or for any substring, is to start from the lowest color to the darkest color that you need. And you don't want to color like colors you don't need, obviously. Like I don't need to color D here, or like if this was D, I don't need to color C, if that makes sense. But yeah, so the optimal strategy for here is color all of A, so you can reach both these spots. Then after that, color the middle part B, and finally color the final middle part C. Okay, and so that's kind of the optimal strategy, but there's also more catches, of course. Let's just like switch it up a little bit. Let's swap A and B. Okay, and this actually costs a minimum of 4 tries instead of the previous 3 over here. Okay. And that's because this A is in between the two B's. So where last time like in last time, you can color a contiguous segment of all B's in these three, because there's no like required area that's need to be painted less. You have to paint two contiguous segments, so like this segment and this segment. Okay, and everything else is the same. So you paint everything A because all of them are lower than A. Then you have to paint this as B. I'm going to paint this as C. And then you get your exact string. And so this could get complicated real quick, because then you have like multiple segments, and then you have to deal with multiple letters. And let's say like there's a C over here, right? And you can't make a contiguous segment right here because A and B are both less than C. So it just gets really complicated, and I was like, what am I gonna do? So at first I was like, let's just do like a prefix sums, maybe get like a all of one query to find like the required amount of cost greedily, but that didn't work. It got really complicated easily. I think there is a prefix sum solution, but I think I just implemented it incorrectly. But what I saw in the editorial, which was actually a really nice solution, including stacks. So I don't use stacks that much in competitive programming, and I'm not really too familiar with it. I need to get better at it. But the idea is kind of simple. Actually, like I said earlier, we have to divide the problem into its prefix and its suffix. If I remember, this is the right string for B. A, B, B, A, B, C, B. Yeah, cool. So what we can do is, let's just calculate the prefix where, like, what is the cost from here to I? So I being from 0 to n. So let's just start. Okay, the cost for A would just be 1. The cost for nothing is 0, of course. The cost for AB is 2 because there's 2 different times I have to paint. ABB would be 2 because I can color all this A, then color this segment B. So I can color all this A and then color this segment B. ABBA, nothing changes. I can just color everything A and then color this part B. Okay. And then nothing changes again. I just add A. Same idea here. Just color them all A. And then same thing with B. Now here, this is 3 because I still can color all of it A, but I can't color one contiguous segment B because there's 2 A's blocking it. I'm going to erase this I for a second. And then maybe C, yeah, it's a new letter and I can't do anything about it, so 4. And for B, it's going to be 4 too, because when I'm painting this second segment, what I can do is I can paint all A, paint this B, and then I can paint over here B, and then paint C up here. So that's a strategy, and that would be at most 4. Yeah, so this is kind of the prefix that we're looking for. So we're going to have 2 arrays, the prefix of the required cost from 0 to L, or 0 to I. And this is important because when we have that empty spot, like in the query, so the query asks for, I think I said this earlier, but if you were to clear these out and have like unpainted area, you would try to paint a fence exactly the same, except this is unpainted. I explained that really weird. But yeah, we really only need to care about its prefix and its suffix. I mentioned that earlier, but yeah. And then we can also do its suffix too. So same idea here. So B, it's a new letter, starts off with 0. C is a new letter, so we have to add another operation. B could be 2 because we can just paint all this B and C. A, it's a new letter, I have to add it. A, I can add it again, like 3, because we can paint this contiguous segment. B, that's going to be another operation because this segment can't be connected to this segment. B right here, it's going to still be 4 because we can connect all of this here. And A, everything can be painted in A35. There's no added. So yeah. Then the question comes, so for your answer, right, you can just query this and then query this, or like, so in the in the, what do you call it, sample test case. In the sample test case, you want to get rid of this and paint just the ends. So A, B, and CV. A, B, and CV. And so what you would need to do is you can just use these, find the prefix, so it would cost 2. And then right here, find the prefix here, and it would cost 2. So the total would be 4. And it's really nice. You can just do O1 queries, and you'll be fine for each end. So that'd be great. Yeah, so the next question is, how do you generate this prefix array? Yeah. So there's multiple ways to do it. There's possibilities for prefix sums. My solution was really complicated, so I decided to change it to the editorials, which is actually really nice. And the idea is to use stacks. Stacks is a data structure that you can peek at the very top value, and then you can easily pop it off O1. So like, just kind of like imagine a queue, if you know what those are. And yeah, I think queues are so open though. I don't know, but stacks are pretty unique. And so yeah, just imagine like a bunch of plates, and like you can't take the bottom plate out or else you're gonna break all these top ones. So you only take the top one at a time. So yeah. But the idea is kind of like this. So I'm gonna pull up a BBA, A, B, C, B. And so I'll just check my code real quick. So yeah, I made this function make, which generates the prefix or suffix array. I can just use make again. Basically, the suffix is the exact same, except you just reverse the string. And this $sign is just to make it so that it's a 1 base indexed. So yeah, it's just easier for me. Yeah, how you do it is that, like, let's just say this is the stack right here. And so if the, okay, yeah. So this just means, this is kind of like prefix where the answer is equal to the guy before it. You can either add on top of it or decrease it. And so, yeah, if the, okay, so if the stack is empty, we obviously add it, okay, because there's a new letter that we need to add, or there's a new segment that we need to add. So let's just add A. And that costs 1 operation, right? B, it's a new letter, so we'll add it. And how it detects a new letter is kind of like if the top of it is less than, so the top end is A in this case, and if it's less than the new letter that we're going to put in, it costs 1 more operation. And this is equal to the top, so nothing changes. This is less than, so nothing changes. This is less than the top, nothing changes. This is equal to the top. Actually, wait. Oh, yeah, I forgot. This is less than the top. So what's going to happen is we're going to pop off everything in the stack that is greater than this value. Because remember, we have to keep track of those segments, right? Those segments so that like this doesn't have like a possible solution, right? This, we just got to keep track of these segments. And so that way we'll just pop off these guys until it's less than or equal to the top, which is A. And then we're good. Yeah, so if it's greater than, we just pop it. If it's empty, that means we have to start a new segment again. I'll take the top minus TR. So yeah, we don't have to add it and we don't have to add anything. But yeah, it's still gonna be 2, 2 actually. Now B is greater than the top, so we have to add it back. And that costs 1 more operation. C is greater than the top, so we have to add another operation. And B is less than the top, so we'll pop that guy off. But it still costs the same though. as the one before. And remember, this is kind of like piggybacking off the guy before. I think I explained that really tough, but this solution works because not only does it keep track of segments, and so yeah, but every time it keeps a sort of hierarchy, because every time, like if you check the stack wherever it is, the bottom is always going to be the lightest color, then it's going to be the next highest, then it's going to keep on going till the stack is at the top. And this hierarchy makes it so that if you're deleting like letters, that means you're deleting the possibility of the segment. So if I added C right here, and remember right now B is at the top, that means I would have to add another guy up here, and that would cost one more operation. So it keeps track of, like, kind of the top letter tells you what type of segment will not cost anything, or like actually anything less than the top segment, it will not add to the operation. So if I added an A, it's still going to be 5. Okay. And so basically, in summary, the top guy, the top person in the stack, is going to represent the maximum color that it could sustain so that it doesn't add any cost to the operation or cost your answer. And so, yeah, and then once you find like a guy or a person that is less than the top, the top changes to that guy. And also, it also keeps track of new letters too. So let's say I add like a T, which is extremely large. So actually, I'm gonna erase the A. So let's say I add a T, right? Since T, actually, wait. Yeah, let's add T and let's add B. Okay. Let's say I add T, right? And so I'm gonna add T to the stack because it's greater than C and it's gonna cost 1 more. Then I'm gonna have D. So I'm gonna pop off T off the stack. The stack's really ugly. But you'll notice that since it's still greater than C, we still have to add it. And with the stack, it also accounts for how many letters have been accounted for. So if it's not in the stack, there's no way to make a contiguous segment. And it also counts in like any additional letters as well. So the benefits of stack is that it keeps a hierarchy. 2, counts segments. And 3, it accounts for new variables or new colors in this case, so new letters. So yeah, that's kind of the summary of No Time to Paint. I'll go through the code real quick. I did look through it just in case because it's pretty complicated and I'm still not good at stacks, but I'll make this easier to read. Like I said earlier, so it's going to piggyback of the guy before it, just like a prefix sum. And so we'll only add to answer if the guy on the top, which is the maximum possible color that it doesn't add to the cost. And if it's greater than, we'll push this guy, so this becomes the new maximum. And ands also increases by 1. And so what we can also do here is, since the prefix or the suffix is basically just the prefix if you just reverse the string or any array. And so we just reverse it. And this $, like I said earlier, keeps it so that it makes it a one base indexed. And then right here, what we do here is we'll just take the prefix of this area and the prefix of R, or the suffix R, and we're good. And R is also n minus R because it accounts for the first R positions, or first 2 R positions, or like positions from the right, if that makes sense. So yeah, that's No Time to Paint. I would say actually this is the hardest problem. A lot of people, I remember a lot of people actually liked or thought it was pretty easy, but I actually had a lot of trouble with it because I don't really do a lot of stacks, and there are probably, I think there is a prefix sum solution, but I was just having a lot of trouble with this one. So, but yeah. Next on the list would probably be spaced out. But yeah, I'll be spaced out later. So yeah, that's it for No Time to Paint. Thank you for watching.